Hi and welcome to video 3 on this video series on motion and differential equations in motion, and this is from Unit 4 Topic 2 of the Specialist Math curriculum. So we're going to talk about motion expressed as differential equations and how we might go about using those, but in this case it's a fairly simple process building to a little bit more of a complex process with a couple extra formulas for us later on. So we can deal with the acceleration as a function of t because that gives us the v to t equals a function of t and v equals the integral of f of t. And if velocity is a function of t, then dx to t equals a function of t and x is the integral as well. We've dealt with that. What about if acceleration is a function of velocity? Well, that means that dv to t is equal to a function of velocity. But we now know how to deal with that because we just bring this over, giving us this, and therefore time can be written as an integral of that reciprocal of the function of velocity, which for the sake of being able to integrate it using logs, we hope that that's a linear function. Of course, it may be a quadratic function, in which case it might be able to be written as a factored quadratic, and then you'll get something to do with partial fractions, x minus alpha plus b over x minus beta. Also, that should be a v, but you get the point here. So there are other options. It may be that it's the square root of 4 plus x squared or something, and it ends up being an inverse sine or an inverse cos. So there's a few different options, but this is the most common. We could do this similarly for velocity equals a function of x. We can solve these with our differential equation knowledge. Let's have a quick look at an example. So question 5 or example 5. A particle is moving in a straight line with velocity with respect to x. Vx equals 3x minus 10, where x is the displacement of the particle at any time t relative to the origin O. Determine an expression for the particle's acceleration. Now we want acceleration in terms of x, but remember acceleration is d squared x to t squared. So we'd have to derive this with respect to t, which is quite tricky. So what we're going to do instead is we're going to determine x as a function of time, and then we're going to rearrange that. So we'll get t as the function of x, and then rearrange it to get x as a function of time, and then derive it twice. And that will be the process that works. But of course, we want acceleration as a function of x, so we might look for opportunities to bring that information in as we move forward. So let's have a look. We know that v is a function of x. Well, we know v is equal to dx dt, and that's equal to 3x minus 10. So we can solve this differential equation by writing it as 1 over 3x minus 10 dx is equal to 1 dt. So I've divided through by 3x minus 10, and I'm going to integrate both sides of that. And of course that gives me log 3x minus 10, and that should be an absolute value there. And when I divide by the derivative of the inside, I get over 3, and that's equal to t plus some constant. Now I'm going to multiply by 3 to give me log 3x minus 10 is equal to 3t plus 3 times a constant, which is still a constant, so I'll just leave it as c. And now I'm going to rearrange this so that x is a function of t. So I get 3x minus 10 is equal to e to the 3t plus c. And that gives me 3x is equal to a e to the 3t. I've brought that constant down as an a, separating my exponentials out. And that's plus 10. And then I'm going to divide through by 3, giving me x is equal to a third a e to the 3t plus 10. Okay, so we've gotten to there, which means that we can now derive, so we can do d to t of that to determine our velocity. So I get velocity is equal to 3 comes out the front, and I end up with just a e to the 3t, and the 10 disappears, and then I d to t the next velocity here to give me acceleration is equal to 3 times a e to the 3t. But of course I wanted the acceleration as a function of x. So I need to think to myself, well, what does a e to the 3t equal? And here's a e to the 3t, although I didn't write it like that until there. and it's equal to 3x minus 10. So therefore acceleration is equal to 3 times 3x minus 10, or 9x minus 30. That of course is the factorised form, but this might be more useful in some cases. So there we have it. There's an example of how we might use differential equations where in particular acceleration, velocity or displacement are not functions of time but functions of one of the other motion variables. All the best.